Hello students, so in this part we are going to study about the concept of modulation. Modulation is an important process which is done at the transmitter stage of every communication systems. We are also going to see what are the different requirements of modulation process. So let's start with the modulation. Hello students, so in this part we are going to study modulation and its NEET. First of all, let us see what is modulation. Modulation is a basic requirement. It's a basic requirement for transmitting the message signal through free space. So first of all, the modulation is a basic requirement. That is, it's a necessary step. Whenever you want to send a signal through free space. It is the process of transmission of information signal, usually a low frequency audio signal, using a higher frequency carrier wave. That means it is a process by which we are sending a low frequency signal by using a higher frequency carrier signal. So we will be using one signal that will be called as a carrier signal, and that will be a higher frequency signal. So this signal will help us our information signal, which is a low frequency signal, to transmit through the free space. Now transmitter modifies the message signal into a form which is suitable for transmission over channel, which is achieved by modulation. This also we have seen when we are discussing the block diagram. We have seen that the transmitter, the main purpose of transmitter is to convert the signal into a form which is suitable for the channel, and that is achieved by the a device called modulator. In that basically does the modulation. So it converts the message signal in the form which is suitable for the transmission over the channel, right? So we will be studying this, right? What is modulation? So that in a better way in the coming slides. First of all, let us see what is the need of modulation. What is the need of modulation? Why we are required this modulation? So first of all, the first reason is the height of transmitting and the receiving antenna. The height of transmitting and the receiving antenna depends upon your modulation frequencies. The height is basically the height of any antenna, whether it is a transmitting antenna or receiving antenna. So height should be greater than wavelength by 4. That is, height of antenna should be at least greater than lambda by 4. Now you can imagine from here, that if the wavelength is higher, the height of antenna will be also higher, and if the wavelength is lesser, the height of antenna will also be lesser. Now we want that antenna height should be less. We don't want that the tower should be of a height very large, right? We want the height of antenna should be medium size or less. So for that, wavelength should be less. That means the frequency should be higher. Therefore, if we send a low frequency signal directly through an antenna, then in that case we will require a very large size of antenna. Therefore, we do the process of modulation. That means we convert the low frequency signal into a higher frequency signal, and then we transmit through an antenna, so that the requirement of height of antenna is reduced. The second reason for the modulation is noise and the interference from the other sources at low frequencies. This is called as multiplexing. So basically we multiplex the signal, so that now what is this multiplexing? That is basically we are converting a lower frequency signal. Let's suppose if you see the signal on the frequency spectrum, this is a lower frequency range and this is a high frequency range. So we will be transmitting our signal from from the lower frequency band to a higher frequency band. So that there will not be an interference and the noise from the other signals. Let's suppose there will be two sources. Both are sending the voice signals through the antenna. Now both will have the same frequency band, so there will be an interference in the frequencies component, right? Therefore, to avoid this interference, we multiplex them in such a way, or we transmit or we translate the frequencies to a higher band such that they are separated. They will not be interfering. Third reason is narrow banding. whenever we transmit our signal from low frequency band to higher frequency band, since we have seen that in the higher frequency band we are having a more bandwidth. Okay, whenever we are going for high frequencies, we will have more bandwidth. That means the relative bandwidth will decrease, okay, as compared to the band in the lower frequencies band. Okay, so there's narrow banding. So the band of a signal as compared to the bandwidth of a channel, okay, or of a channel will be very less when we do this modulation. The fourth requirement is the bandwidth limitation of an equipment. So there are some equipments which has some bandwidth limitations. They cannot, let's suppose there may be an equipment which does not support which cannot support the low frequencies, right? Therefore we will have to convert it into such a frequency range so that it can be supported by the equipment. Therefore for this all these purposes we need the modulation. Let's see one example, one practical example. Okay, I am taking this example for a radio transmission. Let's suppose I want to send my voice signal. Okay, first of all I will use a microphone that will convert my voice into an electrical form. Then the job comes to for a transmitter. Transmitter will convert this signal in such a form that it will be usable, or it can be good supported by the channel in an efficient way. Now we know that the audio signal basically lying in the range of 20 Hz to 20 kilohertz. Okay, and we have seen that the antenna height is greater than, it should be greater than lambda by 4, right? So size should be greater than or equal to lambda 1/4 of wavelength, right? So at 3 kilohertz, if we see that at 3 kilohertz, if we take, let's suppose, any frequency in between this, at 3 kilohertz, the wavelength is equal to C by F, that is speed of light divided by frequencies, right? Frequency of signal. So if we find out the wavelength, it is coming out to be 100 kilometer. Now, so if we divide lambda by 4, it will come out to be size of or the height of antenna will come out to be 25 kilometer. Okay, it is impractical. It's a too large antenna. If we are mounting an antenna of a size 25 kilometer, it will be a very tall, right? We do not require this such a height. Therefore, we will modulate this signal on a higher frequency band so that this wavelength gets reduced and this height requirement will get also reduced. Okay, let's see. So this is basically a practical. Let's see what is basically the practicability of antennas. So we know that the height should be equal to lambda by 4 for efficient transmission. So let's suppose if we take an example of 30 Hz frequency. So for 30 Hz frequencies, the height should, if we calculate the height, that is lambda by 4, it will come out to be 2500 kilometer, which is again a very large height. If we increase the frequencies up to 3 kilohertz, then the height is comes out to be equal to 25 kilometer. Again, it's a very high height. Again, if we increase the frequencies up to 3 megahertz, then the height of antenna comes out to reduce up to 25 meter. So this is a practical height. So we can have. Therefore, we want that. So therefore, we convert the lower frequency signal into a higher frequency signal, so that they can be efficiently transmitted through an antenna, as well as the antenna height is also a practical height. Okay. Thus, we can say as the frequency increases, the height of the antenna decreases. Fine. Therefore, now we can define the modulation. So basically, the modulation is defined as the process by which some characteristics of a signal called carrier is varied in accordance with the instantaneous value of another signal called modulating signal. This definition seems to be very difficult. Okay, let us simplify this. First of all, first focus on these two things. Okay, one we are having a modulating signal, and another one we are having a modulated signal. Okay, so the information bearing signal. So the signal which is our information, that is the signal which we want to transmit, that is called as a modulating signal. Okay, and the signal which is result after the process of modulation is called as a modulated signal. Okay, and see, so there are basically two types of waves and signals. One is our modulating signal, which is our information signal, and second is a carrier signal. Okay, carrier signal is a high frequency signal which is used for converting this low frequency signal into a higher frequency signal, and the resultant signal which is called as a modulated signal. So this will be a signal after modulation. This is the signal, that is the modulating signal is a signal before modulation, and carrier signal is a signal which is used for modulation of a modulating signal. So let's see what are the types of modulation. First of all, if you see any sine wave, okay, or a carrier wave. So basically for the purpose of carrier wave, we choose a sinusoidal wave. Okay, so sinusoidal wave can be described by three parameters, that is amplitude, frequency, and the phase. Okay, let's suppose if we take any sine wave, so it will have an amplitude A, it will have phase phi, it will have an angular frequency omega. So there are three parameters by which a sinusoidal wave can be defined. Okay, so now we can change. So our information, now which we want to send our transmit our information. Okay, so that information we can either send through only changing the amplitude of this sine wave, or by changing the phase of this sine wave, or by changing this frequency of this sine wave. That means there will be sine wave. Okay, and our information which we this carrier wave is a high frequency wave. Okay, and the information which we want to send will be a low frequency signal, right? And so that information we can either send through amplitude, frequency, or phase. So on basis of this, we have three types of modulation: either amplitude modulation, frequency modulation, or the phase modulation. So these are the three types of modulations, okay, which we house. Let's see one example, okay, and let's see how much we have gained till now. A 100-meter long antenna is mounted on a 500-meter tall building. A complex can become a transmission tower for waves with less than 400 meter, less than 25 meter, less than 150 meter, and less than 2400 meter. So basically we have to find what should be the appropriate wavelength, okay, for that. So basically we have seen that the height should be greater than lambda by 4. That means the wavelength should be less than 4 times the height. Okay, if the wavelength is less than 4 times the height, then there will be our transmission will be efficient, and the height of antenna will also be in a practical. So the height will be a practical height, right? So we are given a height of antenna is 100 meter. Okay, it is mounted over 500 tall building. So we don't need to consider this building height. We are only concerned about the height of antenna. So we are given the height of antenna is 100 meter. Okay, so now what should be the wavelength so that we can easily transmit our information through this antenna? So for that we know that the wavelength should be less than 4 times the antenna. That means the wavelength should be less than 4 times 4 into 100 meter, that is wavelength should be less than 400 meter. If the wavelength is less than or equal to 400 meter, then only we can send our signal through this antenna of height 100 meter, otherwise we won't. Okay, therefore the waves should be less than 400 meter. Therefore A is the correct answer. Let's see another example. So what is the frequency above which the radiation of electrical signal is practical? What should be the frequencies, right, above which the radiation of electrical signal is practical? Now we know that first of all the height of antenna, okay, should be greater than lambda by 4. Okay, so we know that the height is directly proportional to wavelength. So there should be, so we want that wavelength should be less. Okay, and we know that the wavelength is equal to C by F. That is, wavelength is inversely proportional to frequency, or we can say that the height is directly proportional to frequency, inversely proportional to frequency, right? So for a less height, if you want the height of antenna should be less, the frequency should be higher. So more the higher frequencies, lesser will be the height of antenna required, and that will be good for our system. So we want the signal to be of a higher frequency. Okay, so therefore if you see in the example, so we can directly answer that the 20 kilohertz is basically a frequency having the highest frequency among these four frequencies. Therefore, this should be basically a frequencies, okay, above which the radiation of electrical signal is practical. If we will decrease the frequencies below this, then it will not be a practical. Okay, then see, if we choose, let's suppose answer D. Okay, so this option C also has a frequencies which is greater than 10 kilohertz, right? Therefore, C will be, so the highest frequency will always be the subset of our answer. Even you can verify from here that you can do one thing. We are given the frequency is 20 kilohertz. So find the wavelength from here and then find the height. Okay, height from this frequencies. And if you are getting it around 1 kilometer or less than, I mean, we want it should be less than 1 kilometer, around 200, 300 meter, 500 meters sufficient. Alright, so you can easily calculate from there. So, but directly I can say that the answer will be option C. Hello students. So in this part, we have studied about the concept of modulation. Modulation basically shifts an lower spectrum of a signal to a higher spectrum. This helps us in reducing an antenna size. We have also seen the different advantages of using modulation process at the transmitter stage. In the next part, we will be going to study about amplitude and frequency modulation. So stay tuned with us.